Hello all, welcome back to my channel Gateway to Computer Science. Today's topic of discussion will be process control block. So what happens is whenever a process is created, apparently one process control block is also created. So what is process control block? Process control block is a data structure that is used in operating system to store all the data related information to the process. Whatever data is related to the process, it will be stored in process control block. And if you haven't subscribed to my channel yet, I would request you to please subscribe to the channel, and if you will find this information useful, please like and share this video. So let's understand the process control block with the help of a diagram. So this is the diagram of process control block which will be present in most of the operating system. See, the compartments or the attributes of process control block can differ from one operating system to other operating system, but this one is something that is basic and that is general and mostly asked in exams as well. So let's understand each of these attributes one by one. So what happens is whenever a process is created, apparently process control block is also created. How is process created? First of all, process is created with the help of system call. We'll understand what system call is in the further videos. Okay, so what will happen is whenever process is created, apparently many process control blocks will also be created. Now what happens when this process control blocks when the process is getting terminated? When the process will complete its execution and gets terminated, then what will happen is whatever resources were allocated to the process will be given back to the operating system. So now this is also a resource that was allocated to the process when it was created, right? So on its termination, even the process control block will be given back to the operating system. Whatever things will be there inside the process control block will be emptied, and the same block can be assigned to new process. What happens is there will be n number of processes running, there will be many processes created. So you can't always be creating new process control blocks, right? Like for each process you will be creating, but after termination of that process, if you won't reuse it, then you will be just wasting that PCB. And if you will be keep on creating the new blocks, what will happen is it will lead to more storage, right? So what will happen is when one process is getting terminated, the PCB will be taken and it will be emptied and it will be assigned to a new process. Now let's understand the attributes of PCB. Okay. So first comes process ID. Process ID is nothing but a unique ID that is given to each and every process. It is a unique ID given to each and every process so that it can be identified by the operating system. You will be having n number of processes. For us it will be like whenever we take process, it will be like P1, P2, we'll write it that way for our understanding, but it's not like that to the process. There will be multiple processes created, so the process has to understand and differentiate between each and every process. That is the reason process ID is given to each and every process, okay, so that it can be identified by the operating system. Then comes process state. We have seen various states of process type, like creating, new state, ready state, running state, waiting or block state, terminated state. Process state tells us exactly in which state the process is present at that particular point of time, whether it is created and it is in new state, or else it is already sent in the RAM and it is ready for its execution, or it is getting executed and it is in running state, or else it has gone for any input output handling, or if it is in wait or block state, or if it is completed its execution, then it will be terminated state, and then the terminated state processes data will be taken, even the PCB will be taken and given to a new process. Next comes the program counter. So program counter is something that points to the previous executed instruction. I'll explain to you with help of one example. Now suppose consider we have two processes, increment and decrement, that are running parallelly. Okay, we have certain instructions for executing increment process and we have certain instructions for executing decrement process. So what happens is, the steps for incrementing is, first you'll have to load the value, and then you'll have to increment the value and then store the incremented value. Here also in decrement, similarly we have to load the value first, then decrement, and then store the decremented value. For example, here in one process, now increment is getting executed. Now in between, like first it will execute the first instruction, okay? Then it will execute the second instruction, fine. Now what will happen is, it will have to go and handle some interrupt. Now what will happen is, decrement will come into the picture. Then what will happen, it will do its decrementation process, then it will, just assume it will also execute 2 of its instructions. Now what this program counter does is, now already 2 instructions are executed, right? So it will point where the last instruction was executed by the process. What was the last instruction that was executed by the process? That it will point there, so that the next instruction can take place. That is how program counter works. Okay. So it will be pointing to the instruction that was last executed, so that the process can continue its execution with the next instruction. Then we have priority. Priority attribute tells that in which what is the priority of the process, what if it is like of higher priority. We'll learn that in the priority scheduling, okay. We'll know how the priority is given to the process in priority scheduling. So priority tells us that what is the priority of the process, okay. Then we have general purpose registers. General purpose registers, what they do is, they'll hold and they'll keep all the data that is related to the process, okay. So whatever data is generated during the execution of process, that will be present in the general purpose registers. Then we have file list, which in all files were used by the process during its execution. Everything will be in file list, okay. And then we have device info, on which device the process is getting executed. For example, if you're taking a picture also, it will tell, no, on so and so device, on so and so time the picture was taken and all of it. So device info will tell us about like in which device the process is getting executed. Then we have protection. As we have already seen, one of the function of operating system is to provide protection. So what happens is, when process is getting executed, the other process should not come and interrupt the execution of one process. So that's how the operating system provides protection. And see, the process, what happens is, it does not get executed in secondary memory, obviously. It will get executed in RAM, right? That is the main memory. So whenever a process is getting executed in main memory, it does not access, the main memory is not accessible to the normal users. So that's how the operating system is providing protection, and this is about the process control block. In my previous video also I had asked about the questions, important questions that I'll make according to the video syllabus for each subject. So if you want me to make questions, I'll make a separate playlist of all the important questions. If you want me to make the playlist, just comment questions in the comment section. And if you find this information useful, please like and share this video amongst your friends as well. And if you haven't subscribed to my channel yet, please subscribe to my channel. Thank you for watching. Have a nice day.